Hello everyone. In this lecture, we will explore how to program effectively using AI tool GitHub Copilot. We will not just use the code generated by AI as is, but rather examine how developers can collaborate with AI to write better code. In this session, we will develop a program to print a diamond shape using Copilot. We will be using Visual Studio Code and the GitHub Copilot extension. A separate guide for setting up the development environment has been provided, so please prepare your environment and follow along with the demonstration. Learning by doing is much more memorable. All right, let's implement a program to print a diamond shape. We will ask Copilot as follows. Create C++ project to print a diamond shape. Project name is Shape Printer. Copilot will generate a C++ project and configure the workspace. Click the Create Workspace to create the project workspace. Specify the folder where you want to create the project. I will create it on the D drive. Click the Select as Parent folder to create the project workspace. A message will appear asking if you want to open the created workspace. Click the Open button to load the created workspace. A build toolkit for the project is selected, and CMake will prepare the build configuration for the project. If you look at the src folder, you will find the main.cpp file. Looking at this file, you can see that a program has been generated to print a diamond shape of a given size. The upper part prints the top half of the diamond shape, and the lower part prints the bottom half. Press the Launch Application button. The program will be built and executed. Enter 5 as the size of the diamond shape. The diamond shape is printed correctly. However, if you only verify and use the program by running it like this, the code generated by AI can become technical debt for you. Eventually, you may end up spending more time due to bugs or requirement changes. You must thoroughly verify the code generated by AI before using it. To do this, it is essential to strengthen your code review skills. Also, you need to consider if this developed program is really what you want. It works, but this is not the program I desire. I want to develop a highly maintainable program that can flexibly respond to various future requirement changes. What kind of changes can we expect? First, there might be requests to print various shapes other than a diamond, such as a cross or a circle. Also, there might be requests to output to a file instead of the console, or to change the output character from an asterisk to a capital O. Better software is less affected by these changes and is easier to maintain, and I want to develop such high-quality software. AI does not independently understand quality requirements such as the project's business context and performance, or maintainability requirements. These are the parts that developers must clearly understand and specifically request from AI. Now, let's ask Copilot what the expected requirement changes of the program are. What are the expected requirement changes of the program? Copilot describes changing the character used for output and outputting to a file instead of the console stream. However, it did not identify the requirement change regarding the variety of shapes to be output. As you can see, AI lacks the ability to perfectly understand the project context or important requirements. Of course, it is not easy for developers to properly perform these roles either. AI can be a good assistant to support developers in these activities. Now, let's improve the program to easily support modifications and output of various shapes. Enhance the program easier to modify and support various shapes. In response to the request, Copilot defines a diamond class that extends a shape class. The diamond class has a print function to print the diamond. The main function is modified to use the diamond class. Let's add printing a triangle. Add to print a triangle. You can see that a triangle class has been added to print a triangle shape. In the main function, the user is given options to select the size and shape to print. However, this approach is also not the software design I want to increase ease of modification. I want to clearly separate the program that defines the shape and the program that prints the shape so that changes to the shape definition do not affect the output logic. So, I will try to enhance the design with the following command. A shape can be defined as a function. Modify the program to take a function defining the shape as an argument and print the shape. Now, Copilot has generated a generalized function called printShape. Since a shape function that defines the shape is provided as a parameter, the print shape function is not directly affected by the definition of the output shape. However, this program is also not the design I want. The print shape function simply calls shape function and does not include any generalized implementation logic for printing the shape. How can we effectively separate the generalized implementation from the shape printing from the shape definition? Think about it. This is a moment where your creative problem-solving skills are needed. Well, here's a way. If we define the shape with a function inside shape that returns whether a given coordinate is inside the shape, and the print shape function prints the shape based on the result of the inside shape function, we can completely generalize the output logic. AI still has limitations in independently devising a way to define a shape through the inside shape function and suggesting a creative solution that allows the print shape function to generalize the output. These creative problem-solving or design decisions remain the responsibility of the developer. Now, I will give Copilot the following command. Instead of print diamond, use inside diamond that returns whether the given coordinate is inside of a diamond or not. Following this instruction, an inside diamond function that defines the diamond shape is generated, and the print shape function prints a character based on the result of the given inside function. Now, even if another inside function is added, the print shape function can be reused without modification. This design provides great flexibility when adding or changing new shapes. Now, let's add printing across shape. Add to print across. The inside cross function has been added, and we can now print across shape using it. At this time, the print shape function was not modified at all. This means it is not affected at all by the definition of the shape to be printed. Click the Apply button. This will reflect the code generated by AI in the workspace. You can apply or not apply the changes one by one. You can apply all changes at once with the Keep button. Click the Keep button. You can see that the code edited by Copilot has been applied. Click the Launch button. Enter 3 for the size and for diamond output. Run it again. Enter 3 again and C for cross output. You can see that the diamond cross shapes are successfully printed. Looking at the program, the print shape function displays a bitmap of size 2n-1 by 2n-1, printing an asterisk if the coordinate is inside the shape according to the result of the inside function, and a space otherwise. This program is much simpler and clearer than the previous version, significantly improving code readability. The inside diamond function determines whether a given coordinate is inside a diamond. Specifically, for x and y coordinates, it is considered inside the diamond if the sum of the distances from the center point is less than the size of the shape. On the other hand, the inside cross function defines it as being inside the cross shape if either the x or y coordinate matches the center point. The functions that define the shapes have also been improved to be intuitive and easy to understand. The enhanced program offers several advantages over the previous version. First, code readability is improved, making code review easier. Second, the roles of functions are clearly separated, making it easy to verify functionality with unit tests. Third, the ease of modification is greatly improved because the print shape function does not need to be modified when adding new shapes. This kind of high-quality software development is very important in modern software engineering, and we must continuously strengthen our ability to develop such high-quality software together with AI. In this lecture, we explored the limitations of AI tools and the role of developers through a simple program that prints a diamond shape. AI helps with code generation, but it has some clear limitations. First, lack of understanding of business context. AI does not independently grasp key elements such as the project's business context or important quality requirements. In the diamond printing program, shape changes are easily foreseeable requirement changes, but AI can miss them. Second, limited creative problem-solving and design ability. While AI can implement well-known algorithms or patterns well, it still has limitations in suggesting solutions optimized for specific problems that arise in the field. It is difficult for AI to spontaneously propose creative designs such as separating shape definition and output, or defining shapes through the inside shape function. Third, inability to guarantee code accuracy. Code generated by AI is not always accurate and perfect, so developer verification is essential. Due to these limitations, some developers hesitate to use AI tools. However, AI tools can be powerful partners that help developers focus on more valuable work. First, support for focusing on core tasks. Since AI handles repetitive coding tasks, developers can focus on more important tasks such as requirements analysis and optimal solution design. Second, assisting developer decision-making. Developer identify important requirements, review solutions, and make final decisions. AI collects and summarizes the necessary information during this process. It presents various alternatives and supports decision-making. Third, productivity improvement. AI can significantly shorten the development cycle and improve productivity by quickly implementing specified solutions, writing documentation, and generating test cases. Fourth, value as a learning tool. AI promotes developer learning and growth by showing various coding patterns and the latest technologies. AI tools are evolving at a very rapid pace. The situation can be described as different yesterday, different today, and different tomorrow. Now, learning how to use them effectively, rather than avoiding them, is a key factor in strengthening a developer's competitiveness. A shift in perspective is needed, viewing AI not just as a code generator, but as a collaborative tool for complex problem-solving and creative design. Ultimately, AI and developers have a complementary relationship. AI provides speed and consistency, and developers provide creativity and understanding of the business context. Through this collaboration, we can develop higher quality software more efficiently. In the next, we will leverage the powerful capabilities of GitHub Copilot to further advance the diamond shape printing project. The shape printer we will create will have the following elegant design. The core logic, the shape_printer module, acts like the heart of the program. It is responsible for the basic flow of drawing and printing shapes. The shape extension shape_extension module independently defines and manages various shapes such as diamonds, crosses, and circles. Adding new shapes does not affect the core logic or the output method. It's like easily fitting various shapes together like Lego blocks. The output method extension module can display results in various ways, such as console output and file output. Adding new output methods does not affect the core logic or shape definitions at all. It supports printing shapes in various ways. Thanks to this excellent design, we can independently extend and verify each part. Just like a well-organized team, each performs their assigned role efficiently, improving the quality of the entire system. You can check the final completed shape printer in the GitHub repository. If you look at the code directly, you will be able to further appreciate the beauty of the design we are pursuing. The following 11 lectures will interestingly show the process of the shape printer project being gradually completed, like a drama. We will continuously find and apply improvements and collaborate with AI tools to create software of the desired quality. Through this, you will experience how to pair program effectively with AI. In the next lecture, we will take the first step in the shape printer project. We will create the shape printer project. We will implement the print shape function and the inside diamond function. The result of the first step can be found in the OnePrint shape using inside shape branch of the GitHub repository. Before taking the lecture, take a moment to think again about the goal of the next lecture. And I highly recommend that you try writing code directly with Copilot. The insights gained from directly encountering and pondering problems will be much more valuable than simply listening to the lecture. AI tools will be your excellent assistants. Let's work together to create a wonderful shape printer.